Hello dear friends, welcome to my channel Infinity Learn Mathematics in a Simple Way. So today we are going to solve the remaining problems on 3 marks on the topic relation and function. So let us try to solve the problem. Show that the relation R in the set A is equal to 1, 2, 3, 4. See the question here. Show that the relation R in the set A is equal to, what is the set given here? A is equal to 1, 2, 3, 4, 5, given by the relation A comma B such that mod of A minus B is what? Even. Mod of A minus B is what? Even. Is an equivalence relation. This question has been asked in the year July 2016 and March 2018. Let us try to understand this problem. First, write the solution right here from here A and write the relation, given relation. R is reflexive. So here R is reflexive because mod of A minus A is equal to 0. 0 is an what? Even number. 0 is an what? Even number. Mod of A minus A is 0. Here, what is the given relation? A minus B is an even. So first, in the reflexive relation, we are comparing A to A. That is mod of A minus A is what? 0. 0 is an even number. Therefore, A comma A belongs to R for all A belongs to A. So it is R is what? Reflexive. Now for symmetric, R is symmetric. R is what? Symmetric if A comma B belongs to R. If A comma B belongs to R, it means what is the relation A comma B belongs to R means what? Mod of A minus B even. Mod of A minus B even. And it's a reverse, that is mod of B minus A is also even. If A comma B belongs to R means what? We are writing mod of A minus B is even. Then it's reverse. If mod of B minus A is even, then we can write B comma A also belongs to R. Therefore R is what? Symmetric. Therefore R is what? Symmetric. R is transitive. R is transitive. For transitive relation, A comma B belongs to R and B comma C belongs to R. A comma B belongs to R means mod of A minus B is even, and B comma C belongs to R means what? Mod of B minus C is also even. By the definition given in the relation, if A comma B belongs to R, it means mod of A minus B is even, and B comma C belongs to R means what? Mod of B minus C is even. Then adding these two, A minus B and B plus C, B minus C, A minus B plus B minus C is also what? Even. So that B get cancelled here. A minus C is even. A minus C is even means what? Mod of A minus C is even. It implies A minus C is even means what? A comma C also belongs to the what? The relation R. Therefore R is an equivalence relation because it is reflexive, symmetric and transitive. Next question, show that the relation on A is equal to X belongs to Z. Show that the relation on A is equal to X belongs to Z. 0 is less than or equal to X. X is less than or equal to 12. Defined by a relation R is equal to A comma B. Mod of A minus B is a what? Divisible by 4. Mod of A minus B is what? Divisible by 4 is an equivalence relation. This question has been asked in the year March 2016. Here A is equal to, first write the set A is equal to. See here A is what? Belongs to the Z. Z means what? Set of integers. Starting from the what? 0 and is what? 12. So we are writing the elements of the set A is equal to by using this condition, that is a set builder form it is given. We are writing this set builder form in terms of the what? Roster form. Here A is equal to 0, 1, 0 to what? 12. 0 up to the what? 12. First R is equal to, and we have write the what? Elements of a set in roster form, that is 0 to 12, 0, 1, 2, 3, 4, 5, 6 and so on up to the what? 12. Then the relation, what is the relation given here? R is equal to A comma B. Mod of A minus B is a what? Multiple of 4. Sorry, divisible by 4. It's not a multiple, it is a divisible by 4. Divisible by 4. See here, divisible by 4 it is. So here is also what? It is divisible by 4. Divisible by 4. R is reflexive because mod of A minus A is what? 0. 0 is divisible by what? 4. Therefore it implies what? A comma A belongs to R for all A belongs to A. Therefore R is what? Reflexive. R is symmetric. R is symmetric. A comma B belongs to R means what? Mod of A minus B is what? Divisible by. It is not a multiple. If it is given multiple in the question, you have to use multiple. Here in the question it is given what? Divisible. So you have to write divisible. Yes, divisible by 5. R is symmetric means what? R is symmetric. Let A comma B belongs to R. A comma B belongs to R. Means what is the given definition in the relation? Mod of A minus B is what? Divisible by 4. If A comma B belongs to R means mod of A minus B is divisible by 4. It's a reverse. That is B minus A. Minus B minus A. We are writing its reverse. Minus B minus A is a divisible by 4. Is divisible by 4. Then it implies mod of B minus C is also divisible by 4. Divisible by 4, it means B comma A belongs to R. It means B comma A belongs to R. So therefore R is what? Symmetrics. This implies A comma B belongs to R. Then it also implies what? B comma A belongs to R. It is the what? Condition for what? Symmetric. Therefore R is what? Symmetric. And the third one is R is transitive. For transitive we have to prove the what? This one. A comma B belongs to R and B comma C belongs to R. If A comma B belongs to R means what? Mod of A minus B is a divisible by what? 4. Is divisible by 4. I am writing here. Mod of A minus B. A comma B belongs to R and B comma C belongs to R means what? Mod of A minus B and mod of B minus C is R divisible by 4. Divisible by 4. This implies A minus B and B minus C are divisible by what? 4. Are divisible by 4. Adding these two, A minus B plus B minus C is divisible by 4. Is divisible by 4. Therefore B get cancelled. A minus C is also divisible by what? 4. Divisible by 4. Therefore it implies A minus C is divisible by 4. Is divisible by 4. This implies if A minus C is divisible by 4, then A comma C belongs to R. Therefore R is an equivalence relation because R is reflexive, symmetric and transitive. Next problem. Show that the relation R in the set of real number. Show that the relation R in the set of real number R defined R is equal to A comma B such that A is less than or equal to B square is not reflexive, not symmetric and not transitive. We have to show this one. R is not reflexive. For example, A is equal to 1 by 2 belongs to R, but 1 by 2 comma 1 by 2 does not belongs to R as 1 by 2 is greater than the what? 1 by 4. What is the definition in the relation given here? A is less than or equal to B square. That is 1 by 2 is less than or equal to 1 by B square means what? 2 square. That is, this implies 1 by 2 is less than or equal to what? 1 by 4. It is false because 1 by 2 is what? Greater than 1 by 4. Therefore R is not reflexive. Therefore R is not reflexive. R is not symmetric. R is not symmetric as 1 comma 2 belongs to R but 2 comma 1 does not belongs to R. See the definition here. 1 A is less than or equal to what? B square is given. 1 is less than or equal to 2 square. It is true. But 2 is less than or equal to 1 square. It is false. See here. 1 comma 2 belongs to R but 2 comma 1 does not belongs to R. Therefore R is not symmetric. Therefore R is not symmetric. R is not symmetric. Not for transitive. R is not transitive. For example, take A is equal to 5, B is equal to 3, C is equal to 2. See here, 5 is less than or equal to 3 square and 3 is less than or equal to what? 2 square. It is true. 5 is less than or equal to what? 9. It is true. then 3 is less than or equal to what? 4. It is also true. But what is the value of A? 5. 5 is less than or equal to what is the value of C? 2. 2 square. And 5 is less than or equal to what? 4. It is false. It is false. Therefore, 5 comma 3 belongs to R and 3 comma 2 belongs to R. 5 comma 3 belongs to R and 3 comma 2 belongs to R, but 5 comma 2 does not belongs to R. Therefore, R is neither reflexive nor symmetric nor transitive. R is neither reflexive nor symmetric nor transitive. Next, show that the relation R in R defined as A comma B such that A is less than or equal to what? B cube is neither reflexive nor symmetric and not transitive. R is not reflexive because as we did A is equal to what? 1 by 2. Take A is equal to 1 by 2 belongs to R. It is a real number, but 1 by 2 comma 1 by 2 does not belongs to R because as 1 by 2 is what? Greater than 1 by 8. Here what is the definition? A is less than or equal to what? B cube. 1 by 2 is less than or equal to 1 by 2 cube. It is not possible because 1 by 2 is what? Greater than 1 by 8. Therefore, R is not reflexive. R is not symmetric because 1 comma 2 belongs to R but 2 comma 1 does not belongs to R as we did in the previous problem. See once again example for what this one symmetric. I will explain the same symmetric by taking the values. Here A is equal to 1. A is equal to what? 1 is less than or equal to 2 cube. 1 is less than or equal to 8. This condition is true. A comma B belongs to R. That is 1 comma 2 belongs to R. But it's a reverse. 2 is less than or equal to 1 cube. 2 is less than or equal to 1. This condition is what? False. But 2 comma 1 does not belongs to R. Therefore R is what? Not symmetric. Therefore R is not symmetric. In the case of what? Transitive. Come to the what? Transitive. For transitive, take an example. By taking an example, we have to give the reason. It is to show the what? It is not transitive. R is not transitive. R is not transitive. A is equal to 10, B is equal to 3, C is equal to 2. So A is less than or equal to B cube and B is less than or equal to C cube and A is less than or equal to C cube. We have to show these three conditions. If it is true, then it is what? Transitive. If it is not true, then it is what? Not transitive. A is what here? 10 is less than or equal to what? 3 cube. B is what here? 3 and 3 is less than or equal to what? 2 cube and 10 is less than or equal to what? Sorry, A means what? 10. C means what here? 2 cube. See here. 10 is less than or equal to 27. Condition. 3 cube. B means what? 3 here. 10 is less than or equal to 27. It is true. Yes. 3 is less than or equal to 8. It is also true. A is less than or equal to B cube. B is less than or equal to C cube. These two conditions are true. But A is less than or equal to C cube. That is 10 is less than or equal to 8. 2 cube means what? 8. This condition is false. Therefore, 10 comma 3 and 3 comma 2 belongs to the relation R, but 10 comma 2 does not belongs to R. Therefore, R is neither reflexive nor symmetric nor transitive. So this completes the what? Solution of the problem. And come to the what? Next problem. Show that the relation R defined in the set of all the triangles as T1 comma T2, T1 is similar to T2 is an equivalence relation. This question has been asked in the year what? March 2020. So for this one we are going to solve the what? Here in the next page. See here. To prove this one we have to write here reflexive. Reflexive. R is reflexive. Reflexive as T1 comma T1. T1 is similar to T2. T1 is similar to what? T1 itself. As T1 comma T1 belongs to R for all T1 belongs to set of all triangles. Set of belongs to A. A means what? Here set of all triangles. T1 belongs to A. Here A means what? Set of all triangles. A means what? Set of all triangles. Yes. Therefore R is what? Reflexive, because we are comparing with the what? T1 to T1 itself. T1 and T1 are what? Similar triangles, we can say. And symmetric. For symmetric, T1 comma T2, as T1 comma T2 belongs to R, it means T1 is similar to T2. T1 is similar to what? T2. Okay. T2 is similar to T1. I am writing in the reverse order. T2 is similar to T2. Is it possible? Yes, it is possible. So this statement we are writing in the what? In this manner. If T2 is similar to what? T1, then T2 comma T1 belongs to R. Therefore R is symmetric. R is what? Symmetric, we can say. R is what? Symmetric. Next, for transitive. For transitive, as T1 comma T2 belongs to R and T2 comma T3 belongs to R. T1 comma T3 belongs to R. T1 comma T2 belongs to R means T1 is similar to T2. T1 is similar to T2. It means, and T2 is T2 comma T3 belongs to me. R means what? T2 is similar to T3. T2 is similar to what? T3. This implies if T1 is similar to T2 and T2 is similar to T3 means what? T1 is also similar to what? T3. Therefore T1 is similar to what? T3. This implies if it is T1 is similar to T3 means what? T1 comma T3 belongs to what? R. T1 comma T3 belongs to R. This implies R is an equivalence relation. Equivalence relation. Because R is both reflexive, symmetric and transitive. Therefore, because R is what? Reflexive, symmetric and transitive, then the relation is said to be what? Equivalence relation. Next one, let L be the set of all lines. Next problem, let L be the set of all lines in xy plane and R be the relation. Let L be the set of all lines. L be the set of all lines in xy plane and R be the relation in L. R be the relation in L defined as L1 comma L2. L1 is parallel to L2. Show that R is an equivalence relation. Yes, right here first the relation R is equal to what? L1 comma L2. L1 is parallel to L2. R is reflexive since every line is parallel to itself. That is, this implies L1 comma L1 belongs to R. For all L1 is belongs to the what? L. L is the what? Set of all lines. Set of all lines in the what? XY plane. L1, since every line is parallel to itself, means L1 comma L1 belongs to R for all L1 belongs to L. Therefore, R is what? Reflexive. Next, R is symmetric. R is what? Symmetric. R is symmetric. L1 comma L2 belongs to R means L1 is parallel to L2. If L2 is parallel to L1 means what? L2 comma L1 belongs to R. Therefore, R is what? Symmetric. R is what? Symmetric. R is a transitive. R is what? Transitive. If L1 comma L2 belongs to R and L2 comma L3 belongs to R, L1 is parallel to L2 and L2 is parallel to L3. This implies L1 L3 is also what? Parallel. Therefore, L1 comma L3 belongs to R. Therefore, R is what? Transitive. Since the R is what? Reflexive, symmetric and transitive, then R is what? R is an equivalence relation. R is what? Equivalence relation. So these are the what problems on types of relation and equivalence of relation. So these all problems are very important for the point of your annual examination. So these problems carries the what? 3 marks. Thank you so much for watching. Thank you so much for watching my channel.